Alright, I came across this interesting problem dealing with sinusoidal functions and phase shift. I'm going to try to interpret it. And right or wrong, I'm going to interpret what I see, and then we will type it in and we'll see if I get it right or if I get it wrong. Either way, you'll find out a problem that the Khan Academy has written. So it looks like Thomas ties a weight to the minute hand of a clock. So what I'm going to do is I'm just going to draw a clock. Alright? And I know I'm going to do it. I'll do a small little hour hand. All right, I'll put it right about there. Okay, and then we'll draw on a minute hand, say right here. Okay, but we'll just kind of want you to, the minute hand can be anywhere on the clock, so I'll just go ahead and let's see here. I'm going to put a minute hand right there. And it looks like it says he ties a weight to the minute hand of a clock. So I'm just going to pretend like he ties a knot and he puts a weight that's dangling right here. I'm just going to make a weight. Let's pretend like that's the weight that's tied to the minute hand. And then the minute hand goes all the way around. And it says the clockwise torque applied by the weight varies in a periodic way that can be modeled by a function. So it says the torque peaks 15 minutes after each whole hour. So it peaks. The maximum is going to be basically 15 minutes after each whole hour. When the minute hand is pointing directly to the right, so right here, this is the maximum, at 3 Newton meters. So basically, what we're going to say is we are going to say our maximum is 15 minutes after, our time is 15 minutes after each whole hour, and it has a maximum of 3 Newton meters. And then it says the minimum torque of negative 3 newtons occurs 15 minutes before each whole hour. All right, so we put minimum. All right, so basically like at negative, we'll say negative 15, comma 3. Not negative 15. Basically our minimum is at negative 3. All right. So basically, let's think of it this way. If this is 15 minutes after the whole hour, 15 minutes before, that would put us at 45 minutes. So we could say 45 minutes. That's still 15 minutes before the hour. Now it looks like he started this process at 10:55, which is 5 minutes before. I'm going to write 5 minutes before the start of an hour. I'm going to call this is 12. So we'll say there's the 12. So we started this at 11:55. So I think this is going to be dealing with phase shift. So I'm going to put phase shift. I'm going to put is minus 5 minutes. Minus 5 minutes. All right. So I'm going to draw a little graph here, and then we're going to take this graph and apply what it looks like. All right. So let's think about this. If we have a sine graph, this kind of follows the period of a sine graph. You start out at the midline, then it reaches its maximum, goes down to its minimum, which is right here, and then eventually it reaches up back to its maximum once again. But right now, I'm going to break it down into 15-minute intervals. All right. So I'm going to call this 15 minutes. All right, each of these is 15 minutes. And so what they're saying is after the first 15, and basically the period is an hour. So the period is 1 hour, also known as 60 minutes. So our period is 60 minutes. It reaches a maximum height of 3 and a minimum height of negative 3, and it happens at 15-minute intervals. All right, so each of these are a quarter all the way through. So that's going to kind of help me build my function. So when I build my function, I think it's L of t, or sorry, T of t. So we have T of t, time, and the distance from the midline to the maximum is the amplitude, so I'm going to call it 3. I'm interpreting it as a sine function. And the period of a sine function is always 2 pi, but our period is 60 minutes. So I'm going to put 2 pi over 60. And then I'm going to apply the phase shift, because he didn't start this graph. He didn't start this graph until it was 11:55. He didn't start it on the hour. So I'm going to put like t minus 5. T minus, not t minus 5, duh, t plus 5. Because negative 5, you have to plug in a negative 5. And then our midline is just at 0. It doesn't start up or down. It starts at 0, so I'm just going to leave it like that. So this is how I'm going to type it in. And once again, there we go. Once again, this is our amplitude. All right, it started 5 minutes before the hour, and the maximum occurs every 15 minutes. All right, and so I did 2 pi over 60, being that we have 60 minutes is the entire period broken down into quarters. All right, so I'm going to go over here, and we will go ahead and type this in and see what happens. I'll either get it right or I won't, and at this point, I'm going to type in my 3, sine, open up the parentheses, make a little fraction bar, put 2 pi, scroll down a little bit, where's pi? There it is. Pi, open up parentheses, I'm going to put t plus 5, because it was 5 minutes before the start of the hour, total of 60 minutes, and they say not quite. All right, let's see what they wanted. Amplitude is 3, got that. Pi over 60, got that. This is 5 minutes after midnight. I said 11:55. That's 5 minutes before midnight. Why would they put t minus 5 instead of t plus 5? Let's see what they said here. Since midnight is 5 minutes after so I guess they wanted t minus 5 instead of t plus 5. Well, I hope you come across this problem and just write down my answer. Did the right concept, I just interpreted the 11:55 as being before midnight and interpreted it as a plus 5 instead of a minus 5. Either way, hope you get a free problem.